All right, guys. So now we're going to talk about another thing that can happen with covalent bonds. So we all know that water is super, super important. It's a solvent of life, and when water moves across a membrane, it's called osmosis. Water's super, super special. Most of the chemical reactions in our body are taking place in water because we're mostly water. So water is super, super special. And I wanted to show you atomically what's going on there. So I did the math here. H2O is our molecule, so it's 2 hydrogens, 1 oxygen. So I did the math here to figure out the protons, well, we knew the protons, the neutrons and the electrons present. So I'm going to go ahead and draw the Bohr model of this. And the reason I'm doing this is to show you that if you can visualize these Bohr models, a lot of times it's going to help you when you're taking the test or when you're doing something to think, oh yeah, okay, if I know what that looks like, I may be able to figure out what it's going to do. So first I'm going to start with the oxygen. So that has 8 protons and 8 neutrons, and it has 8 electrons. So there's 2 on the first shell, 1, 2, 3, 4, 5, 6 on the next shell. So this guy needs 2 to be happy, right? And then we have our hydrogen atoms over here on the side, and it has 1 proton, 0 neutrons, and just 1 electron. And I'm going to draw the other one over here. Oftentimes when you're drawing like CO2, you put the carbon in the middle and the oxygen's on the side just to help you with the drawing. So this is 1 proton, 0 neutrons, and here's our 1 electron. So each one of these hydrogens needs 1 electron to be happy, and this oxygen needs 2. So we know in this case it's going to be a covalent bond because nobody's just giving away, this guy's not just going to give away his electron. Oh, you can just have it, So they'll share this electron here. They will share this electron here. Now everybody is happy. However, if you're an electron, so you're a little minus sign, and you're zipping around, so you're going to zip around this way and then zip around this one. Remember how we said they're shared? So he's zipping around. Are you more excited as a little minus sign hanging out here by this 1 plus sign or hanging out over here by 8 plus signs? If you're a little minus sign, you want to be over there with the 8 plus signs. But the electron is being shared, right? You can't just jump over there. So what ends up happening is the electron zips around here, but then he spends like a lot of time over here. So he's like loving it, loving it, loving it, loving it, loving it. Oh yeah, I gotta do this too. But loving it, loving it, loving it, loving it, loving it, loving it, loving it. Gotta do this too. Loving it, loving it. Oh my God, oh my God, oh my God, oh my God, oh my God. Gotta do this too. Yay, 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 yay. Okay? Other guy's doing the same thing. So he is zipping around here really fast, and then, yay, I love hanging out over here. Oh my gosh, zip around real fast. Oh, this is so fun over here. Oh my gosh, zip around real fast. Oh, yay. So what ends up happening is the electrons spend more of their time around the oxygen, okay? Now they're going around both because it's shared, but they just spend a little bit more time over there, okay? So what ends up happening is this oxygen, this end of the molecule, gets this kind of pseudo negative charge. That's what that little thing, kind of pseudo fakey-ish, right? Negative charge. And since these guys, the electron is not over there very often, they get kind of a pseudo positive charge, okay? And so there are positive and negative poles on this molecule. It's a polar molecule, okay? So now if we have another water molecule, because when have you ever just had one water molecule? Like, I'll just take one, thank you. No, that doesn't work. So if we have another water molecule over here, so we have, here's the O and here's some H's, right? And then we have another one. What happens is this is kind of positive and this is kind of negative, right? And this is kind of positive and this is kind of negative. Well, the kind of positive and the kind of negative kind of interact with each other. So they interact, and these guys interact, and these guys interact, okay? It's a real quick interaction. It's a short electrostatic interaction, transient, very transient, like breaking and reforming, breaking and reforming, breaking and reforming. So it is between 2 molecules, not within one. So within the 1 molecule, we have a covalent bond. It's a polar covalent bond. It's an unequal sharing of electrons, but it's a covalent bond. Between two water molecules, we have what we call a hydrogen bond, which is a transient electrostatic interaction. And this hydrogen bonding is what gives water a lot of its properties because it bonds to itself. So if we think about things like gasoline, right? Gasoline is a big hydrocarbon molecule. It's way bigger than one little teeny water molecule. It's way heavier when we're talking about atomic weight. So you would think for a molecule of gasoline to evaporate, right, to turn from liquid to gas, we would have to apply a lot of heat. For this water molecule, we wouldn't have to apply that much because it's way lighter, so it should be able to float away way easier. That's what you would think. But we've all been there before. We've all been pumping our gas and we like see those wavy lines and we're like, oh my God, right? Wasting all my money in the summer, it's all floating away. Well, what the hell? If that molecule is way heavier than water, why aren't all the lakes evaporating? Why am I not evaporating, right? I'm mostly water. Well, thank the freaking Lord that there's hydrogen bonding, because that hydrogen bonding is what keeps that water molecule bound to itself. That's why we have to apply so much heat to get it to evaporate. When it evaporates, those hydrogen bonds break, and it takes more energy to break those hydrogen bonds. The gasoline, they don't care about each other. The water molecules are like, or the gasoline molecules, whatever, you can evaporate, I don't care, I'm not holding on to you, whatever, okay? And this is one of the really cool properties of water. If you look at the PowerPoint, you'll see a bunch of other ones. All right, bye guys.